Hello students, good evening and welcome to APJ Academy. So we know that our JEE exams second session is going to uh, get conducted soon. Like it starts from 25th of this month and already admit cards have been released. I hope that all the students who are writing the second session would have downloaded their admit cards and everything is kept right. Everything is kept ready for your turn to appear to you. Okay, so dear students, as you have already seen in the thumbnail, today we are going to discuss the states of matter. We are starting a new chapter, and today we are going to discuss mainly two topics, that is basically the gas laws, which are important, and also Dalton's law of partial pressure. No, actually not that, but we are going to discuss about the laws of effusion or diffusion of gas. Okay, so that's the topic that we are going to discuss today. So before getting started to the topic, let me give a brief introduction regarding our academy as well as myself. So a brief introduction, that is, we are providing quality classes for NEET and as well as for JEE aspirants. Okay, this is all about our full year course. You can see what all we provide. We provide the PDF materials of all the complete modules along with the bank of questions, and also we conduct test series which is 25 major test series according to the NTA pattern we conduct. Yes, Nisha, how are you? Then we have query solving, then we have lessons up to and soon after every lesson we have assignments, right? So yes, so you can crack JEE or NEET with this enormous discount, just 490 rupees per month. Okay, so if you are watching this channel for the very first time, you can subscribe to this channel, so that I am sure that this will surely add value to your preparations, right? And this is all about me. That's what I am. And if you are thinking that who is this person, you can just read who I am, right? Okay, now dear students, today we are going to discuss about the gas laws. Okay, so gas laws are those laws which are related to gases. Okay, and we should understand what gas laws are, then only we can practically, or we can assume, or we can understand the properties of gases, right? So we know that states of matter is a chapter from physical chemistry, so you can expect numerical questions from this topic. So it is very important and necessary that you understand each and everything from this chapter. So let's get started. We are going to discuss about Boyle's law. First of all, I will also introduce certain tricks in order to remember actually what each law is. So you know that Boyle's law means, actually we know that you might have familiar with boiling, the term boiling, right? Boil. What do you mean by boil? Boil means, you know, boiling water, something you might have very familiar about, right? So when the pressure, vapor pressure of the water, when it becomes equal to the atmospheric pressure, the water from the bulk of the water from the container start to vaporize, and this process is called as boiling. You are familiar with that. That is not my point here. So I am just giving you a trick that if I am asking you about Boyle's law, think about boiling. For boiling, what you have to give? You have to provide temperature or thermal energy. So here for Boyle's law, temperature is the constant variable, though we cannot call it as variable. Temperature is constant according to Boyle's law. So actually, if temperature is constant, then what is Boyle's law saying? Boyle's law is giving a clear guidance on the pressure volume relationship of gas. So let's consider a container. Okay, this container consists of gas, and this is covered with a piston, and I have a piston, and if I exert certain pressure, what happens to the volume? That means now I am increasing pressure over the container. That means if I if I give more pressure, or if I increase the pressure that is acting on the gaseous molecules, what happens is that the volume will get decreased. That means we know that if you apply more pressure, compression will take place, right? The gases will get compressed. We know that gas molecules have large molecular distances, right? Since their van der Waals forces are weaker, we know that the intermolecular distances are large. So they have lots of spaces within the molecules. So what happens is that if you compress, if you give pressure, if you increase the pressure, what happens? The gas will get compressed. That means the volume get decreased. So if you increase the pressure, volume get decreased. Then how they are related? That means they are related inversely. That is, pressure is directly proportional to 1 by V. This is the relation of Boyle's law. So from the term boil, remember that boil, you connect it with boiling. For boiling, what is required? Temperature is required. So Boyle's law is a case where temperature is made constant. So if temperature is constant, then what is the relation? Relation is between pressure and volume. If you increase the pressure, the volume decreases. That means pressure and volume are inversely related to each other. If you increase pressure, volume decreases. If you decrease pressure, volume increases. This is how they are related, and this is all about Boyle's law. Hope this is clear for you students, right? So I have told that pressure is directly proportional to 1 by V. So if that is the case, then you can write, you can convert this proportionality equation into an equality equation by just putting equal to. So if you are converting this proportionality sign to equality, then you have to use certain constant. So I can write it as P is equal to constant by V. Okay, P is equal to constant by V. What does that mean? That means PV is equal to a constant. PV is equal to a constant. Dear students, I wanted to talk about this. Actually, this is a mathematical relation. PV is equal to K or PV is equal to constant. But as a NEET aspirant or a JEE aspirant, you cannot stay there. You have to delve deep into that particular equation and have to understand what is the concept. Okay, so let's discuss that in the next page. See, if I take a particular gas, carbon dioxide, for a particular gas at constant temperature, because we are dealing with Boyle's law, we know that the temperature is constant. So at constant temperature, for any gases, for a particular gas, we know that the pressure into volume, the product of pressure volume will always remain constant. So what does that mean? That means at a constant temperature, if you are changing the pressure, if you are changing the pressure, then we know that for PV to remain constant, what have to be done? See, as pressure is increased, automatically the volume will decrease, and what happens is that PV will again remain constant. Like, I'll give you an example. I am taking a container. Here there is carbon dioxide. Okay. Now, this is state 1. Let's take it as state 1. That means for a state 1, I am applying a pressure of 2 atm. Okay, 2 atm. Let's say an example, that is, for carbon dioxide, the PV value is equal to 4 atm liter. Okay, PV value is equal to 4 atm liter for carbon dioxide. And understand, this value is constant. I am just taking an arbitrary value. Okay, and this value is constant. So here I know that if pressure is 2 atm, then volume should be obviously be 2 liters, right? Then only we get 4 atm per liter. Now what I am doing is that I am increasing the pressure. You know, I am increasing the pressure. I am increasing the pressure and converting into 4 atm, right? Then what will happen to the volume? What will happen to the volume? We know that volume will surely change. How much it change? It will change till we get the value PV equal to 4 atm liter. That means now what happens with this? This is P2 and this is V2. So we know that for carbon dioxide at constant temperature, PV is constant. So here what I did is that from state 1 to state 2, I changed what? I changed pressure. So if I change the pressure, then obviously what will change? The volume will change in order to keep the PV value constant. So if P2 is 4 atm, then what will be V2? V2 will be 1 liter. How I got it? Because we know that PV is equal to 4 atm liter. So in order to get that P2, V2 equal to 4 atm liter, if pressure is 4, then obviously the volume should be 1. Okay, so that's why if PV is equal to a constant, then I can write it as P1 V1 will always be equal to P2 V2, and this is the important relation that you have to understand. I hope this concept is clear for you, because mainly what students learn is that they study it blindly by thinking that PV is equal to constant, and they will blindly learn that P1 V1 equal to P2 V2. But that should not be a case if you are a serious JEE aspirant. You must understand the underlying concept of that particular equation. We are not going to leave any equation like as it is. We have to go deep into that equation and understand what they are telling us. Okay, so this is what they are telling. For a particular gas at constant temperature, the product value of pressure and volume will be constant. So if you change pressure, what happens? The corresponding change will happen to volume in order to make the PV value constant. So at state 1, pressure was 2 atm and volume was 2 liter. Now for state 2, pressure, we have doubled the pressure. Now what happens with the volume? Volume has decreased by half. So what happens there? There nothing happens actually. What happens means the P2 V2 again becomes equal to 4 liter atmosphere. Okay, is that clear? Please let me know in the comment section if this concept is clear for you, then I can go to the next law. Okay, so for cracking JEE, what is the key? The key is understanding the concept with crystal clear clarity. Okay, if you understand the concept with crystal clear clarity, then the JEE seat or IIT is yours. Okay, that's what you have to understand. So I'm giving you time to just analyze what we have told, and if you have any query, you can ask me in the comment section. Okay, so in between, let me know whether you have understood this. So you can just intimate in the comment section so that I can understand whether it's clear for you, or if you have any doubt, please let me know, and please feel free to ask. Okay, any doubt, we are here to help you out, right? Yes, shall we move on? Right. So this is what we have just discussed, that is PV is equal to K, and what I have explained have been described here in little sentences. That is, if a fixed amount of gas at constant temperature T. So for Boyle's law, temperature should be constant, and it's a relationship between pressure and volume. So as you increase the pressure, volume decreases. So at constant temperature T, occupying volume V1 at constant pressure P1 undergoes expansion. So it is undergoing expansion, so that the volume becomes V2. So that the volume becomes V2 and the pressure becomes P2, and the pressure becomes P2. Then according to Boyle's law, P1 V1 is equal to P2 V2. So as I have told, PV is equal to constant for a particular gas. Now if you change the volume or if you change the pressure, PV value will not change. PV will always remain constant. How it is constant? Because if you change the pressure, the volume will undergo a change in order to make that product constant. Okay, so P1 V1 equal to P2 V2, and if you take P2 to LHS and V1 to RHS, you will get this relation, that is P1 by P2 equal to V2 by V1. Is that clear, students? Is that clear? If that is clear, then we are going into the next question actually from this topic. So you can read it. See, a balloon is filled with hydrogen at room temperature. So room temperature in chemistry, normally we take it as 25 degrees Celsius, or we say it as 298 Kelvin. That means now the temperature is constant here. The temperature is constant because they have told We are taking the balloon which is filled with hydrogen at room temperature. So at room temperature means the temperature is constant. Now what's the second sentence? It will burst if pressure exceeds 0.2 bar, and if at 1 bar pressure the gas occupies 2.27 liter volume, up to what volume can the balloon be expanded? This is a very good question. Okay, this question can only be done by those students who have crystal clear clarity on the concept of Boyle's law. Okay, so let's think about this. See, I have a balloon. Okay, this is a balloon I have, and we know that this balloon is kept at constant temperature, that is at room temperature, and at 1 bar pressure. Now the balloon is having a pressure of 1 bar. Okay, 1 bar pressure. Now the balloon is at 1 bar pressure. So we know that at 1 bar pressure the balloon occupies, or the gases inside the balloon has a volume of 2.27 liter. That means the volume of balloon is now 2.27 liter. Now so I can just write P1 is equal to 1 bar, and V1 corresponding to that particular pressure we have the volume 2.27 liter. Now they are asking us up to what volume can the balloon be expanded. So the balloon can be expanded till it bursts, right? The balloon can be expanded till it bursts. So is there any data given with respect to the bursting of balloon? Yes, they have given in the second sentence that it will burst if pressure exceeds 0.2 bar. That means if you decrease the pressure, if I am decreasing the pressure from P1 to P2, say to P2 I am decreasing, what happens with the volume? Volume will get increased. That means from being 2.27 liter, it start to increase to 2.28, 2.29, likewise it goes. So we have to find out that volume until when the balloon can be expanded. That means the maximum pressure I can reduce is to 0.2 bar. If I further reduce the pressure, what happens? The balloon will burst. So the pressure at which the maximum pressure that the balloon can hold, or that is in the reverse order, that means the pressure till which it can reduced is 0.2 bar. That means we have to find out what is V2. So V2 is the volume till which we can fill the balloon. If you increase the volume slightly from above V2, what happens? The balloon will burst. Okay, so we have been given the value P2. Now just find out V2. So here inside this balloon we are only filling with hydrogen. So for hydrogen we know that at constant temperature, at room temperature, it will have PV constant value. So I can use the value P1 V1 equal to, use the equation P1 V1 equal to P2 V2. Here I have to find out what is V2. So V2 is equal to P1 V1 by P2, right? So what is P1? That is 1 bar. V1 is 2.27 liters. And what is P2? That is 0.2. If I divide 2.27 divided by 2.2, I'll be getting a value of 11.35 liters. 11.35 liters. So the maximum volume to which a balloon can expand is equal to 11.35 liters. If you again reduce the pressure from 0.2, what happens? The volume increases. That means it will burst. Okay, that is the question what mentioned over here. Hope this question is clear for you. Please let me know in the comment section if it is clear for you. So the final answer is 11.35 liter volume. Yes, students, are you there? Please let me know if this is clear for you. Right? Okay. Now we will move on to the next topic, that is Charles' law. So here also I am going to bring a trick in order to understand and not to get confused with the laws. And what Charles' law? You know that Prince Charles, you might have heard about Prince Charles, right? Prince Charles. Who is Prince Charles? Prince Charles was the Prince of UK, right? To London. So Prince Charles is Prince. That means it is related to P. That means here P is constant. So pressure is constant. So Charles' law is all about the relationship between temperature and volume. It is temperature volume relationship. So we know that if you increase the temperature, what is happening is that you are giving thermal energy to the volume, to the molecules. So thermal energy is counteractive to the intermolecular force of attraction. So what happens? If you are increasing the thermal energy, the molecules will get detached from the force of attraction which they were previously having. That means they start to expand. As you increase the thermal energy, they start to expand. And what do you mean by expansion? So as you increase temperature, what is increasing? Volume is increasing. So temperature is directly proportional to volume. So if you give volume, if you give more and more temperature to the gaseous molecules, they start to expand, and because of which the volume increases. So we can write that temperature is directly proportional to volume, and I can change this proportionality to equality by using a constant. So I can write it as temperature is equal to K into V, and we can write it as T by V equal to K. That means for a particular gas, temperature by volume ratio is a constant. That means again we can write this relation T1 by V1 equal to T2 by V2. And this is what you have to remember if you want to solve any numerical problems regarding Charles law. So notorious, sir, drop le lu kya? Why you have to give a drop, notorious? Please let me know so that I can give you the proper guidance. Okay. So have you given your JEE session 1 exam? How many marks have you got? Are you already a dropout or just a 12th standard, just a going 12th standard student? So if you are seriously thinking of taking a drop, then understand this thing, that it should be a serious drop. Okay. Take it that this 1 year you are not compromising on anything. Your focus should be fully on preparation, improving your intellectual capacity, improving your knowledge, improving your problem solving skill. So you got 93.35. So don't make a decision that you are going to take a drop. Rather, give your second session. Second session exam starts from 25th of this month, right? So when is your exam? And please let me know whether you have downloaded the admit card. Okay, so give your exam properly. And in this channel we have already given the proper analysis of the session 1 questions. So you go through that, and we also have provided the guidance to how to approach for the second session. So you go through that and prepare accordingly. Okay, and give your best in that exam, and just wait for the result, or just wait for the answer key actually. And if you can score more than 98 or 99 percentile, then NIT is a sure chance for you. Okay. And students who have scored, I am just guessing this year's benchmark, or the benchmark will be around 90 percentile, I think so. So you have already scored 93.25, so you can give a shot on JEE Advance. Okay, so give a shot on your JEE Advance also, and feel that experience. Okay, if you, even if you whether you get the seat in IIT, or whether you qualify for IIT or not, think even if you are going to fail, I'm not telling that you are going to fail, no, give it a shot and understand how the exam is. Feel that exam, and even if you could score good marks, then it's well and good. If you have failed, then consider that it is not a failure. It's just a stepping stone that you going to do well in the next year's exam. So what you have done is that you have felt, you got the feeling of how JEE Advanced exam is. Okay, that's how you have to, with a positive mind, give a proper approach. That's what you have to do. Okay, and one more thing, understand from your failure. In the last year, what have you done? What mistakes have you made? Rectify it. Give time to yourself. Think about what made you create those mistakes. Okay. Then rectify those mistakes and prepare accordingly. That will help you to score better marks. Okay. So now listen here. That's all the guidance that I want to give you. So on the way, as we move on, I'll give you the proper guidance on how to crack JEE. Right. Okay. Now coming back to Charles' law. So what Charles is telling is that the volume of a given mass of a gas increases or decreases by 1 by 273rd of its volume at 0 degrees Celsius for each degree rise or fall of temperature, provided pressure and mass is kept constant. Okay. What does that mean? See, if I take in a container, this is gas actually, and this is a closed container. So let's say the volume of this gas is volume of the container or volume of the gas is how much? Say 1 liter. Okay, and here the temperature is 273 Kelvin, or we can mark it as 0 degree Celsius. 0 degree Celsius. Yes, Notorious, you can just join our Telegram channel. They will be providing my number. Okay, they will give you the number. Just join in our Telegram group, right? So temperature is for 0 degree Celsius, the gas is occupying 1 liter. I am telling that if I am increasing the temperature to 1 degree, that means just 1 Kelvin or 1 degree. What happens now with the volume? Let's check what Charles is saying. Charles is saying that if you are increasing the temperature, then the volume of the gas will also increases by 1 by 273 of its volume. So how much it get increased? It gets increased by 1 by 273 of 1 liter. 1 liter is the volume, or let's take it as 2 liters. Let's take it as 2 liters. You already joined, but it's a bot, it's an PDF and study material. Okay. Right. You please contact the APJ Academy, so that if they are providing you my number, I'm fine with that. Since I'm working under an academy, I cannot make my own decisions, right? So that's the problem. So you can contact them and you can ask my number. If they are willing to give you, they will give you. Okay. So 1 by 273 into 1 liter, or say if I am increasing the temperature by 1 degree Celsius, then how much it is, how much volume is increasing? It is increasing by, let's say I have taken it as at 273 Kelvin, the total volume is 2 liter. So it is 1 by 273 part of 2 liter is increasing. So what will be the total volume? Temperature equal to 1 degree Celsius. The total volume will be equal to 2 liter plus the increased is 1 by 273 into 2 liter. That much is increased. Okay. So you can connect me in the social medias like Instagram or Facebook. Okay. You can connect me there also. Right. So if the temperature is equal to 1 degree Celsius, then the volume will be 2 liter plus 1 by 273 of the 2 liter. Okay. Similarly, if I am increasing the temperature from 0 degree Celsius to 2 degree Celsius, what happens? If I am increasing to 2 degree Celsius, that means how much volume will it get increased? It get increased by 2 by 273rd of the 2 liter. So this much is the increased volume. Okay. So increased volume, and after 2 degrees Celsius or 2 degrees Celsius, what is the total volume of that gas? The total volume will be equal to 2 liter plus 2 by 273 into 2 liter. This is the total volume of the gas, right? So hope you have got the point. If you are increasing the volume, if you are increasing the temperature by 1 degree, how much the volume is increasing? The volume is increasing 1 by 273rd part of the initial volume. So we can generalize that into an equation. You can see here the final volume will be equal to initial volume plus T by 273.15 into initial volume. This is the increased volume. Okay, this is the increased volume. So here you can see that you can just generalize that and you can write it in this manner also. So dear students, I do not want you to study this equation by heart. I want you to understand and feel what they are telling. Feel that equation so that it will be, your conceptual clarity will be proper on that. So if you do not have a proper conceptual clarity, you are not going to crack JEE Advanced. Okay. Yes, there is a massive difference in the content also. It is, you can join APJ Academy. We are going to give you the full content on that. So that's not a problem. Okay. And what you have to do is you have to bring that conceptual clarity so that it will help you, right? So let's hope this is clear for you now. And this relationship already we have mentioned, right? The volume of a given mass of a gas at constant pressure is directly proportional to its temperature on the Kelvin scale. As you increase the temperature, the volume also increases. So this is the relation that I want you to by heart it. Actually, this is by hearting is not required, as you all know that velocity volume is directly proportional to temperature, and you know that V by T equal to a constant. If that is a constant, then V1 by T1 is equal to V2 by T2, and that is all about Charles law. For Charles law, remember about Prince Charles, that is P. So P stands for pressure. So in this case, for Charles law, pressure is constant. So it's a relationship between volume and temperature. As you increase the thermal energy, there will be an expansion of gaseous molecules, as thermal energy is an opposing factor for van der Waals force of attraction. So as you increase the temperature, what happens? You are increasing the thermal energy and the van der Waals force of attraction becomes weakens. It gets weakened. Okay, so that's what the concept all about, right? Now let's solve this problem. See, a gas at 30 Kelvin is compressed to reduce its volume to half of its volume. So we'll take temperature T1 is 300 Kelvin. Okay. Now it is compressed to reduce its volume to half of its volume. So initially its volume was V by 2. Okay, it was V. Now it has decreased to V by 2. Initial volume was V, and now as we have at temperature 300 Kelvin, a gas at 300 Kelvin is compressed. That means to reduce its volume to half of its volume. Now they are asking about at what temperature, that means you have to find out T2, will it become double of its initial value. That means V2 becomes 2 times of V. At what temperature it becomes double of its initial value. So initial volume we have taken as V. This is the initial volume. So at temperature T1 equal to 300 Kelvin, V1 became V by 2. That means half of its volume. Okay. Now we have to find out at what temperature the V2 becomes 2 times the initial volume. So we know that the equation V by T is a constant. So V1 by T1 is equal to V2 by T2. Here what I have to find? I have to find T2. So T2 is equal to V2 into T1 by V1. So V2 is equal to 2V into T1 is 300 divided by V by 2, right? T2 is equal to V2 T1 by V1. So is there something went wrong? I feel so something went wrong. Let's check this. Let's check it once again. Okay. yeah, V1 is equal to, let's take it as V1 is equal to V at 300 Kelvin. Okay, now V2 is equal to V2 is equal to V1 is equal to V at 300 Kelvin, and at what temperature will it become double of its initial volume? So initial volume is V, and it should become how much? It should become the double, right? So let's take V1 is equal to V by 2 and V2 is equal to V. That's what the mistake has happened. So initially the volume was V by 2, and if it is if the volume is doubling, means V by 2 into 2, that means the doubled volume is equal to V. So temperature T1 is equal to 300 Kelvin and temperature T2 is equal to, is what we have to find out. So we know that V1 by T1 is equal to V2 by T2. So here I have to find out T2. So that means T2 is equal to V2 T1 by V1. That means what is V2? V2 is equal to V, and T1 is equal to what? T1 is equal to 300, right? Divided by what is V2 T1 by V1, right? So what is V1? V1 is equal to V by 2. V by 2. So this V and V get cancelled and this 2 goes over there. So it will be 600. Okay. So 600 Kelvin will be the answer. Hope this is clear, students. Please let me know if it is clear for you. Okay. I'm not satisfied with this answer. I think again I have to go through it once again. Let's do it. Just check it once again. Then we will confirm the answer. So let's we are going to read it sentence by sentence. So at 300 Kelvin, it is compressed to reduce its volume to half of its volume. So the volume V1 becomes, let's take initially it has V0. So it gets reduced to half of its volume, means V0 by 2, right? So V1 is equal to V0 by 2. So at 300 Kelvin, a gas is compressed to reduce its volume to half of its volume. To reduce its volume to half of its volume. So reduction actually, right? So reduction means we should not divide it by 2. In fact, we have to reduce it. That's what they are telling. Okay. So what will be the volume here? What will be the volume here? So we can take it as V. Okay. At 300 Kelvin. So at 300 Kelvin, let's take it as V1 is equal to V. Right. Now at what temperature will it become double of its initial volume? It's not V, it should be V1 is equal to half of its volume. That means initial volume is, let's take it as V, so that now V1 is equal to V by 2, right? Now at what temperature, that is you have to find out T2, and corresponding to T2, at what temperature will it become double of its initial value? So double of its initial value means it is equal to, initial value is V by 2 and the final value should be V, right? Double of its initial value means it should become V, right? Okay. Now let's take it, T1 is equal to V1 by T1 is equal to V2 by T2. So V1 is equal to V by 2 into T1. T1 is equal to 300 is equal to V2 by T2. V2 is equal to V and T2. So this is V and V get cancelled. So T2 equal to 600 Kelvin, right? So at 600 Kelvin, it will become double of the initial value. So what we have done previously is the right way. So just got confused with the value. Okay. So this is right, because at 300 Kelvin, what is happening? The volume is decreasing. As we increase the temperature, the volume should increase. So it becomes double at 600 Kelvin. Okay. So that's the answer for the question. Now, what has happened? Okay. Now actually the next concept is all about Gay-Lussac's law, but something is missing, so let's make it here. So Gay-Lussac's law, what do you know about Gay-Lussac's law? See students, Gay-Lussac's law is a relationship between pressure and temperature. It's a pressure temperature relationship. Pressure temperature relationship. What is Gay-Lussac is stating is that as the pressure of a given mass of a gas is directly proportional to the Kelvin temperature at constant volume. Okay. So at constant volume, as you increases the pressure, what happens? The temperature also increases. How the temperature is increasing? You know that as you increases the pressure, there will occurs more collisions between the gaseous molecules and more energy will be released in the form of heat. So what happens? The temperature also increases. So pressure is directly proportional to temperature at constant volume, and this is what Gay-Lussac is saying. So we can write it as P by T is equal to a constant. P by T is equal to a constant. That means P1 by T1 is equal to P2 by T2, and this is all about what? This is all about Gay-Lussac's law, right? So let's check the question. What's the question? A cylinder containing cooking gas can withstand a pressure of 15 atm. The pressure gauge of the cylinder indicates 12 atm at 27 degrees Celsius. Due to a sudden fire in the building, the temperature starts rising. At what temperature will the cylinder explode? And this is the question. Okay. So just write down what all factors or what all facts have been given in the question. So we know that the pressure is given as 15 atm. Initially the pressure is 15 atm, and in the second sentence, that means the pressure that can be withstood by the cylinder or the cooking gas is 15 atm. That is what the first sentence means. Now the second sentence is saying that the pressure gauge means something, an instrument that measures the pressure. The pressure gauge of the cylinder indicates 12 atm, that is P2 equal to 12 atm at 27 degrees Celsius. That means T2 equal to 300 Kelvin. We know that 27 degrees Celsius should be converted to Kelvin, that is 300 Kelvin. Due to a sudden fire in the building, the temperature increases, and now at what temperature will the cylinder will explode? And we know that if the pressure increases greater than 15 atm, what happens? The pressure cooker cannot withstand that. It will burst. So we have to find out T1 actually. Okay. And we know the equation, pressure is directly proportional to temperature. So P1 by T1 is equal to P2 by T2. So P1 is 15 atm. T1 is what we have to find out. P2 is 12 atm by 300. So T1 is equal to 15 into 300 by 12. So if I cancel with 3, I'll get 4 here, I'll get 100 here. If I cancel with 100, I'll get 25. So 25 into 15, 25 into 15, how much it is? 25, 10, 12, 5 and 1, 5, 4, 3, 345 Kelvin, right? 5, 10, 12, 151, sorry, 375 Kelvin, 375 Kelvin. So T1 is equal to 375 Kelvin is the right answer. Okay. So hope this is clear for you students. Let's move on to the next one. Now this is an interesting relation, that is combined gas law equation. So in combined gas law equation, we are combining all the three gas laws that we have studied. So with combination of these three laws, we are eliciting a new equation, that is P1 V1 by T1, or we can say that PV by T is equal to a constant for any particular gas. That means P1 by T1 is equal to P1 V1 by T1 is equal to P2 V2 by T2. So Boyle's law, Charles' law and Avogadro's law, Boyle's law, Charles' law and Gay-Lussac's law combined together, and if you are combining all the three laws, you are getting a equation like this: P1 V1 by T1 is equal to P2 V2 by T2, and this is also a very helpful relation. And I have seen in JEE mains in this year's session certain problems, very easy problems, direct problems, which can be solved just by applying this formula, right? Okay. Now you can see here a sample of nitrogen gas occupies a volume of 320 centimeter cube. It is volume at STP. At STP, what do you mean by STP? The temperature should be 298 Kelvin, right? Temperature should be 298 Kelvin, or you can say that 25 degrees Celsius is what we consider. Sorry, 298, it's 273. 273.15 Kelvin, that is at standard temperature pressure. The temperature is 273.15 Kelvin and pressure is equal to 1 bar at STP means. So I'll take it as T1 and P1. So corresponding to T1 and P1, we have V1 equal to 320 centimeter cube. Now let's check what is the question. Calculate its volume at 546.3 Kelvin and 0.5 bar. So we have to calculate the volume V2, and we have been given with the temperature T2 equal to 546.3 Kelvin and P2 is equal to 0.5 bar. This is what is given. So directly apply the formula here. P1 V1 by T1 is equal to P2 V2 by T2. And if you are thinking when to use this formula, if we have pressure, volume and temperature are variables, okay, if neither of the pressure, volume of temperature, if neither of any of these values are constant, you can use the combined gas law, that is PV by T equal to constant. Okay, so when we have pressure, volume and temperature having different values, and if they are not constant, then you have to use this formula in order to find out the required value. So P1 is 1 bar, V1 is 320 centimeter cube, T1 is 273.15 equal to P2 is 0.5, V2 is what we have to find out, and T2 is 546.3, and I can cancel this and write it 273.15 into 2 is 546.3, right? So V2 is equal to 320 into 2 divided by 0.5. 0.5 is 1 by 2, so that 1 by 2 again goes to the numerator. So we can write it as 320 into 4. That means 0812 centimeter cube. So 1280 centimeter cube is the right answer. Okay. Now this is the last law, that is Avogadro's law. What is Avogadro saying is that it is a volume and number of moles relationship, or you can say that volume and amount relationship. What is Avogadro saying is that equal volumes of all gases under similar conditions of temperature and pressure containing equal number of molecules. Okay, dear students, I wanted to give you a clear picture on this concept. That is, if I take two identical rooms, and the volume here and volume here is same, right? The temperature here and temperature in this room also same, and if pressure here and pressure here is same, so volume, temperature and pressure is same for both the rooms. I have filled this with oxygen molecule and this with carbon dioxide molecule. What Avogadro is telling that if the number of moles of oxygen is 2 moles, then I need not have to find out the number of moles of carbon dioxide. Blindly I can write the number of moles of carbon dioxide is 2. This is what Avogadro is telling. That means we know that in both the rooms we have filled both the rooms with different gases. One is with oxygen, the other with carbon dioxide. But if you are filling 2 different rooms of same volume, same temperature and same pressure, but with the different gases, irrespective of the nature of gases, both the rooms will contain equal number of moles. That means if the first room is containing 2 moles of oxygen, if you are getting that, then without calculating, you can blindly say the second room will surely contain 2 moles of carbon dioxide, irrespective of the nature of gas. So that is what Avogadro's law says, is that if you are considering the same temperature, pressure and volume conditions, even if the gases are different, but the gases will contain same number of molecules or same number of moles. Okay, that means as you increase the volume, number of moles increases. So volume is directly proportional to number of moles. So volume equal to K into N. So V is equal to K into number of moles. We know that you have studied the mole concept, that is mass by molar mass. So I can convert it with this, and molar mass, if I take it on the LHS and bring volume to the RHS, it become M by V. We know that density is equal to mass by volume. So we get it as molar mass is equal to K into M by V. So I can write it as molar mass is equal to K into density. So as you increases the density, molar mass also increases. Or if the molar mass of the gas increases, what gets increased? Density gets increased. Okay, this is what explained by Avogadro. Now, bringing all the laws. Here you have to understand this. You know that there are two categories of gases. One is ideal gas and the other one is real gas. And ideal gas is a hypothetical gas. Okay, for understanding the nature and the properties of the real gases, we have hypothetically developed a concept called as ideal gas. Okay, so what is actually ideal gases? Ideal gas is that gas which strictly follow Boyle's law, Charles' law, and Avogadro's law. If any gas that strictly follows the Boyle's law, Charles' law, and Avogadro's law, then that particular gas is called as ideal gas. And the ideal gas equation is PV is equal to nRT. And this equation is hold true not for real gases but for ideal gases. Okay, in certain questions we consider the real gases as ideal gas and we solve it by using this equation. That's not a problem. Okay, but remember, this is valid only for ideal gas, and for non-ideal gas, or we can say real gases, in the case of real gases we use van der Waals equation. Okay, so that's all about ideal gas. And what is P? P stands for pressure, V stands for volume, N stands for number of moles, and R stands for ideal gas constant. Ideal gas constant. So I want to give you a trick over here. See, ideal gas constant have particularly three values, that is 0.0821 liter atmosphere per mole Kelvin. If you are representing it in bar, then R is equal to 0.083 liter bar per mole Kelvin. That means instead of taking 0.082 or 0.083, just take the value as 1 by 12. Use this fraction. 1 by 12 is nearly equal to these values. So in calculations, you can use the value 1 by 12. And the other value for R is 8.314 joules per mole Kelvin. Instead of using, wherever you are considering energy, there we use the value of 8.314. Okay. So instead of taking 8.314 and multiplying, you can use 25 by 3. This value is nearly equal to 25 by 3. So remember this fraction. So your calculation speed will get much better. And the next value is R is equal to 2 calorie per mole Kelvin. If the question is given in energy and that is in calories, you can use the value of R equal to 2 calorie per mole Kelvin. Okay, this is all about the ideal gas constant, and temperature T stands for the temperature. Now we are moving to the last topic, that is Graham's law of diffusion or effusion. See, actually this is a simple concept. In a container I have certain gases and I am connecting it with another container which is having different gas. This is gas 1, this is gas 2. I have closed it with a stopper. If I release the stopper, what happens? The gases will intermix, and that process is called as diffusion or effusion. Okay, as a gas is intermixing. So how the gas is intermixing, or the rate or the speed of the gas intermixing is, you know that if a boy is fatty, he cannot run faster. Okay, if a boy is slim, okay, he can run faster. So as the molecular mass of the gas decreases, the rate of diffusion increases. That means you can say that if the density increases, rate of diffusion decreases. So rate of diffusion or effusion is inversely proportional to 1 by root of density. And we know that density is equal to mass by volume. That is, density is directly proportional to molar mass or molecular mass. we can write it as R is inversely proportional to root of M. So we can generate this formula, that is R1 by R2 is equal to root of D2 by D1. That is D2 is the density of the second gas and D1 is the density of the first gas, or we can say that the density of the gas in the first case and here the density of the gas in the second case. That is equal to root of M2 by M1. So density is directly proportional to, since density is directly proportional to the molar mass or the molecular mass, as molecular mass increases, the rate decreases. Okay, that is what Graham's law of diffusion or effusion is all about. Just a simple concept that as you grow fatter and fatter, your mobility decreases, your movement decreases, your speed decreases. So if you are filling the container with a large molecules, then what happens? They cannot diffuse that easily. Their speed or the rate the rate at which they diffuse will be very low, and that's all about the concept. So this is all for today's class, dear students. Hope this is clear for you, and please understand the concepts properly, go deeper into the concept and learn it, so that it will help you to crack JEE Advanced. For cracking JEE Advanced, two things you have to remember. One is the conceptual clarity. A to Z, you should not have any minute doubt on a particular concept. That is one thing. Second thing, practice more and more numerical problems, so that it will bridge the gap between your concept and your analytical skill. If you want to bridge the gap between your concept, your learned theory and your analytical skill, what you have to do? Practice more problems. Okay, this is what you have to do. These two things consistently do. Okay, be thirsty. Be thirsty for what? For knowledge. Okay, be thirsty for knowledge. Do not rest until you are happy, until you feel happy that you have understood that concept. Don't be restlessness, show restlessness until you understand the concepts properly. That's the trademark of a successful student. Okay, unless until you are clear with the concept, you have to be restless. Okay, if you have that kind of tendency, if you have that kind of curiosity for knowledge, then surely you are the right person to be admitted in IITs. Okay, students, with that note, I want to wind this session up, and hope this session was fruitful for you all, and I believe that every concept is clear for you. So thank you for